Okay, so today we're in section 8.3, Quotient of Powers. In so many ways, you're going to see similarities between today's lesson and yesterday's lesson, and even bringing what you learned yesterday into some of the examples today. So what is quotient of powers? To divide powers with the same base. So again, that's a similarity to yesterday. They had the same base yesterday also, but now I'm dividing. So when I divide, I'm going to subtract the exponents. All right? But remember my rule that I have to have the same base. Have to have the same base. Okay, so it's going to be important to show step 2. And step 2 will show the common base. Okay, so let's look at the very first problem. 2 to the 6th power divided by 2 to the 4th power. Everybody see where I am? Okay, so you're going to write the common base of 2 and show the exponents that are subtracting. 6 minus 4. And what's 6 minus 4, guys? 2 to the 2nd power. Say, well, we can evaluate. Ms. Skinner, when do I know when I evaluate or when I don't? Yes, the instructions will specifically say on your homework tonight, write your answer as a power. So even though you know what 2 squared is, that's what you leave it, okay? You just leave it 2 squared. Let's look at the next one down. Negative 7 to the 9th power divided by negative 7 to the 3rd power. Does everybody agree? Once again, I have powers with the same base? Yes. Same base? So what does my rule say when I'm dividing? Subtract. Subtract my exponents. Show that step. So I'm going to show you again what I'm looking for. Negative 7, it's in parentheses because it was in parentheses in the original problem, to the 9th power minus 3. Negative 7 to the 6th power. Okay, do you think you could do the other 2? I do. All right, so go ahead and knock out the other 2, and then I want you to compare your answers with someone sitting around you. Okay, so h to the 7th power minus 6 is h to the 1st power, but remember, if it's to the 1st power, do you technically have to write it? No. So I would also accept, and I would say probably the second answer is actually fully correct. But I'm not going to count off either way, because you're showing me if you just write h, which I saw in some of your papers, that you understand that 1 is understood. Okay, 1's just there. All right, so then on the second one, 6 minus 5 is again 1, so I just put 4.2. If you said 4.2 to the 1st power, that's fine also. All right, how'd y'all do? Pretty good? Okay, so in example 2, now you're going to see we're bringing in concepts from what we learned yesterday to what we're learning today. You have to first simplify everything in the numerator and denominator, then simplify the fraction. Okay, so what it's saying is I can't do this division yet because in my numerator this needs to be simplified. Okay, so we always simplify top and bottom of the fraction first, then we would divide. All right, anybody have an idea? What would you get when you simplified your numerator? What would you get, Josh? If you simplify that numerator?
Oh, I know
3 to the...
6.
Yes, 3 to the 6th power. Okay, 3 to 6th power, because I'm multiplying powers with the same base. Because this is multiplication, I would add my exponents. Do you see that? Because it was multiplication?
Yeah.
All right, so really the only way you're going to go wrong on your quiz and test next week is if you forget when you're supposed to add the exponents, when you're supposed to subtract, that type of thing, okay? So with multiplication, I add, but now what am I doing? Okay, so I've simplified numerator and denominator. Do I need to add my exponents again?
No.
I need to subtract them. 3 to the power of 6 minus 3 is 3 to the 3rd power. Okay? All right, so I'm not making you show 4 plus 2 here. Okay? But remember, the more steps that you show, the less chance you have at making a mistake. All right. Okay, try to simplify the second one. Simplify it and then do the division. All right, let's see if we can answer the next two problems based on how we worked the first problem. So when we simplified the denominator, what did you get? 2 to the 8th power. Okay, and now we do 15 minus 8 to get 2 to the 7th power. All right, and I'm pretty sure I saw everybody got that one right, so great job. Okay, then x to the 11th power divided by x to the 5th power would be x to the 6th power. Okay, x to the 6th power. All right, so that's it for example 2. Now let's look at example 3. Example 3, it's getting, I say more complicated, but it's still the same process. All right, we see a lot of terms, a lot of powers here, but they all have the same base. All right, so that's going to help us out a lot. What I would suggest, now this is not the only way to do this, but let's use the same method kind of on all of them so we can form a pretty good habit here. What I want you to do is take each fraction and simplify the fraction first. Okay, so look at the very first fraction, -4 to the 9th power divided by -4 to the 5th power. What would you get if you simplified that fraction, Michael?
Negative 4 to the 4th power.
Perfect, -4 to the 4th power. So does everybody see where I got that from? Okay, so my fraction's gone because I simplified it. So what would you get if you simplified the second fraction?
-4 to the 6th power.
Yep, -4 to the 6th power. And now, how did you know to add your exponents?
Because it's multiplication.
Because now you're multiplying, okay, what was left. So because it's now multiplication, you would add your exponents, -4 to the 10th power. Okay, the other way to do it would have been to multiply across first and then divide, and you would have gotten the same answer. You would have got the same answer. Okay, so what I would suggest, and I'm going to suggest this on this next problem with your A's, simplify each fraction and then multiply those together. Okay, all right, so let's go ahead and work on the next problem. Your a to the 10th divided by a to the 6th times a to the 7th divided by a to the 4th. Okay, for your A's, what did you get when you divided the first fraction? What did you get? A to the 4th power times a to the 3rd power equals a to the 7th. All right, questions on that one? Okay, now on this next one, what did you get when you simplified the numerator? P to the 9th power. Okay. Now, p to the 9th power divided by p to the 2nd, what would you get?
P to the 7th power.
P to the 7th
Oh.
times...
P to the 3rd power.
Wait, how did you get p to the 3rd power? It looks like 4 minus 0, doesn't it?
Understood 1. Understood.
Hey, did y'all catch the understood one? Did you guys remember that? If you've worked this one? Okay. So 4 minus 1 is 3. P to the 10th power. 10th power. Now, this last one, I've got those negatives again that are in parentheses, but look, they all are the same base. So I can keep on with what I've been doing on the other 3 problems. Just want to give you a minute because I know we worked through this rather quickly. I want to give you a minute to finish that last problem if you haven't already. No, for -5. Okay, so we simplify the first part first. -5 to the power of 7 divided by 5. So 7 minus 5 is 2. Okay, you guys see how I got -5 to the 2nd power times -5 to the 4th power. Did you guys get -5 to the 6th power? Okay, very good. All right. So, are they correct? Look at what your friend did. Is your friend correct? But it's division.
No, because it's subtracted.
Right, so when it's division, I'm supposed to subtract my exponents, not divide them. So it should have been, what should my answer have been?
6 to the 10th power.
6 to the 10th power. So I just wrote basically exactly that. I said, no, you're supposed to subtract the exponents, not divide. And then the answer should have been 6 to the 10th power. Okay, so just something along those lines. You have one of these on your homework tonight where it says, like, is your friend correct? All right, and every once in a blue moon, your friend is correct. Every once in a while. But most of the time, they're wrong on the homework assignment. Okay? What about this challenge question? Do you think it's really much of a challenge?
No.
I mean, we're not going to let pi psych us out, right?
It's basically the same thing.
It's the same exact thing, except it's just pi. So while it looks a little fancier, like, ooh, you know, it's still the same process, right? Okay. So is there something I would want to simplify? Micah?
You have to add 18 and 4.
Yep. And what do you get? Okay, so you get pi to the 22nd power. And then pi to the 30th is still on top. And when you divide powers, do they have the same base?
Yes.
Then you subtract the exponents. So 30 minus 22 is 8. Okay, so even if it seems like complicated, it's really not.
Wait, how'd you get 30 minus 22?
Because 18 plus 4 down here is 22, and then I would subtract them. All right, guys, that'll wrap up 8.3, and you're because of the holiday, it's gonna be a little bit of a shorter test. Normally, this test would be over through 8.4, but it's only over these 3 sections, which could make for a pretty good test outcome. All right, so that'll be it for this unit.
And that's everything